AIXU Pro View or what have you, the system tab. I hope we never do. But in essence, that's the idea. It's abstract at that layer. But what we need to do is then get this data that's being collected on individual machines and somehow correlate this data with events going on other machines. So the technique that we're using is you correlate and aggregate data locally using some form of analysis routine. And then based upon event flags in there, you then send asynchronous packets to remote machines, which then may activate other events or commit speculative buffers. dtrace has a notion of speculation where data is recorded in the anticipation that some data will be useful. What we're doing is using this technology, the same type of technology to say speculatively look at stack traces from RPC calls that are coming in on servers, and then we correlate those with asynchronous events that come across the wire from the client saying we're interested in that data, at which point the speculative logs will be committed, and then we can go back and correlate that information in the future asynchronously and use that to produce a complete distributed stack trace coming from, say, a system call in an AFS client going all the way through to an RPC call being serviced in a server, and then from there maybe going on to some database server on the back end, and being able to look at a complete stack trace going across all three tiers, or n tiers in abstract.
So Tom, how do you tag that stack trace to say, how do you identify that stack trace so someone can come back and say that's what I'm
So that's an interesting problem. Something that we've independently developed, and apparently Google has as well, is a notion of where you look at some form of unique identifier that is in every RPC call. With AFS, every call has basically an incremental-based abstraction built into it, and then what you do is you can say, either use statistical sampling, although that has a lot of problems inherent in it. The other way, of course, is doing something like a bit mask and then compare, which gets rid of the inherent problems with statistical sampling. And once you've done that, you can then go back and correlate, some subset of the actual amount of traffic.
So you're made into the semantics of RPCs, like if you're leveraging the
right.
SID or whatever. Okay, cool. Yeah, good idea.
But I mean, obviously, in general, you could do a statistical sample, but there's birthday paradox issues there that don't really help you in the way you collect. But I mean, sort of our theory in general came down to obviously shared state really sucks. I mean, you don't want to do distributed shared memory in a large 1,000-node system you're trying to instrument. So instead, what we're doing is something, to touch on something that was done earlier today. I mean, Erlang is really a great model for doing large-scale distributed systems because there is no shared state. There is no possibility of hash coherence overhead and all that. And obviously, in a distributed system, you don't want to have to deal with that. So what we're doing instead is you asynchronously send messages later. And I think this can fairly easily be pushed into dtrace. And actually, let me just drop something on the whiteboard real quick. I think that.
You pick whiteboard on next to the whiteboard on the stage.
You want this? Sure.
This is on the whiteboard moving highlight reel.
I mean, the idea would be that you just have, normal probe definitions. That's not a good one. Good point. Okay, so we'll just invent some. Never gonna read that. My handwriting is terrible. But let's just say there's some identifier that we're keying off of. The idea would basically be the idea is you would do some sort of like asynchronous send of the variable to some, in our case, it's an n-tier architecture. You have servants. Depending on how you want to do it, maybe you have some central node.
And that can be completely asynchronous.
Right.
Because that obviously can't execute. And then that doesn't have to go execute back to this one.
Yeah.
Right. Cool.
Do you speculate every RPC call? How do you decide what to speculate?
In our case, what we're doing is usually some sort of bit mask on looking maybe at, if you want the last 8 bits to be 0, or something like that. And call it.
Huh.
Are you trying to read an aggregation there?
I'm sorry?
Are you trying to read an aggregation there? Basic settings.
Yeah, so basically, right, you want to, in this case, I'm just sending one index out of the array. But, yeah, I mean, obviously there are other ways to do this as well, but
You actually could do that. That would, I mean, normally you can't read an aggregation value because that's going to be completely asynchronous. You could actually do that use like where the aggregations accumulate, and you could actually require some hypertext syntactic points.
But basically then, I won't continue drawing out, but the idea is fairly simple. From here you would then, on some other node, pull the state in, you would have something else like this on the server that also had a similar bit mask bit, and you could correlate these events, and you would actually see a full stack trace going through multiple nodes just by doing speculation and then asynchronous commits later on. That's really the core idea that we're actually going with, I think.
So where are you in terms of this idea?
Mostly have it working, although bear in mind, the problem is fairly complicated because we have multiple platforms to support. We have a cross-platform and agnostic implementation backend with the dtrace backend, which isn't quite finished yet. We need to have a ProView backend at some point.
Really?
You know, damn you IBM is all I can say, but
So you actually use ProView?
yes.
At.
But that's about all I have. I just wanted to briefly talk about another approach to
Yeah, no, that's very interesting. That's very interesting.
Thank you.
Cool. Thank you. So we're now going to visualization, which I think we're going to define kind of broadly, so we can get DT logger in there. So Rich, yeah, we'll whiteboard off, whiteboard on, whiteboard off. Oh, man.
My use for dtrace is rather different than probably most people's. I'm interested in doing mechanized documentation of software systems, and so you can write scripts to walk through the file tree and find out things about them, but what I want to be able to do is find out which processes get started by what other processes, and which files get touched in which ways by which processes, and so on. And in order to do that, I have to have some kind of a logging mechanism, and dtrace is a really nice front end for that because it can give you fairly arbitrary information. So dtlogger is a configurable logging script. It can run dozens of probes at a time. The only real limit on the number of probes is the amount of kernel space that's allocated for the probes. And unfortunately, Leopard, as far as I know right now, doesn't have any way of changing that number. But when they get that fixed, it'll be a little easier to work with. And I've set up some stuff that allows you to define and use sets of probes. The configuration is done in a YAML file. And this can run in the background for days, and because the output is YAML, it can be read by humans and it can be read by programs easily. And the notion is that the output YAML file will be dumped into a database and then probably accessed by a Ruby on Rails app or something like that. This is a probably far too fancy chart of what's going on. But basically what's going on is the DT record script generates some D probes, and which calls some D macros, and pours that all into the dtrace command, which sends its output to DT record, which records that as a set of files once every minute. And then the DT format guy takes that output and turns it into YAML. This intermediate DTL format that I came up with has to do with the fact that the strings that are being printed are C strings. They could contain quotes or new lines or all sorts of interesting things that would make YAML unhappy. And so DTL is something like Boulder IO format, and I use counted strings so that I can not have that problem. Okay, my implementation right now depends on dtrace, Ruby, YAML, and then this DTL format I mentioned. The kinds of things that I'm trying to ask are, who, what, when, where, and so on. So, for instance, on a system call, I might want to know, which system call it was, and did it return an error, and what was the process ID, and what were the input values, and what was the return value, things like that. That's an example of the YAML output. This is the intermediate format with the counted strings that I mentioned. And then the configuration file in YAML says, okay, there's certain sets of strings that I want to enable or disable, and by playing some games here, I can exclude particular things. For instance, it might be that a particular call isn't supported under Leopard, and therefore I have to exclude that from my set automatically. Things like that. And that's pretty much that. The code is up on CFCL, in case anybody wants to play with it. It's in its second iteration right now, and probably will have a third one coming up, because it looks like the Ruby API may be an easier way of dealing with things. Right now, what I'm doing is running the dtrace command and reading it via pipe. And the Ruby API and the dtrace may be a cleaner way of doing that. Any questions?
So what do you do with the results of that? So once you get all this data, what do you do with that?
Once I have the data, what do I do with it? Well, for instance, if you have, let's say you do a big build run, and you'd like to know which programs got run, what their input files were, what their output files were, whatever. If you can take all of these, the various kinds of information that's being logged here, and put it into a database, you can then crawl through that information and find out, what the order of the activities was.
Well, how can I distinguish between interesting programs like my build program from everything else in the system? There's lots of activity, and there's my build hiding somewhere there. Can I actually extract it from this file only?
Well, I mean, you've got lots of information that will allow you to grab onto a starting point in your data. If you know, for instance, which user ran the command at what time, did you run a make command, and various things like that will be your starting point into the data. Yeah, you're going to have to do some graph work to get all the data back out that you want to get. But it's all in there, and the process IDs are 32 bits these days and things like that. So you've got fairly useful keys.
Couldn't this just be done with progeny of?
Excuse me?
Sorry, it just seems like, for Sasha's question, it seems like progeny of would solve all of that, right? Because progeny of is a dtrace, you can predicate on that, right?
Oh yeah.
Okay.
Go progeny of.
I like progeny of personally, but.
So for those that don't know, progeny of is just it's a D cell routine that returns when if the current process is the progeny of the pit being specified. Okay, good, thank you. All right. We come next to visualization. Now we'll go into more fun stuff. And now for my next trick. This is actually
So what I showed you before is stuff that is interesting, but represents a couple of weeks of kind of hanging around, and is not necessarily asking for product, although if you guys are interested in taking that one, I'm interested. This, on the other hand, is actually destined for product. So you're going to see this show up real soon. So to talk about the problem in the abstract, the dtrace gives us a fantastic foundation for gathering data, but I have personally long wanted to engage the visual cortex on solving problems. In fact, way back in the day, when I was an undergraduate, I developed a tool for that visually showed you the relationship between threads and LWPs in what's called the end-to-end scheduling model, the 2L scheduling model, which was this terrible abortion of an idea that has unfortunately gone to its grave. This thing used TNF it was the only, I believe, runtime consumer of TNF. So TNF was designed to be postmortem. This is doing runtime consumption of TNF. The libTNF wasn't shipped at the time, so I was pulling the data myself, and I had to actually ultimately get in kernel and participate in TNF's locking strategy, such as it was, to get it out fast enough. It was absolutely awful. And much to my chagrin, I discovered when I went to the UK for the first time to present, this guy came up to me afterwards and said, "Wait a minute, you're the guy who wrote Threadmon." Oh my God, this was John Haslam, of course, who since has gone to use dtrace. So I've always been interested in, although Threadmon was a kind of terrible attempt at it, I've always been interested in stimulating the visual cortex and solving problems. We, in terms of software system visualization, we are on starting blocks. We haven't twitched in 40 years, as far as I can tell. People are basically still graphing out case stats. That is the extent. I think the instrument stuff out of Apple is very interesting. I think the Project Unite stuff is very interesting. Both of those projects are really aimed still at the developer. And we make better progress with the developer, for sure. And I think in instruments reflects that, and the enthusiasm for instruments reflects that. But this is my bias. I'm interested in systems that are in production. And in those systems, we have not had adequate visualization. So one of the things that I wanted to go to, I can't remember if you were in this meeting with the tools guys when I was explaining what I wanted to see out of them, and they were like, "No, you don't get it. We want to take our existing broken thing and use some other backend." I'm like, "No, you don't get it. We have a new foundation that allows you to completely change the paradigm." And finally, I was like, "Listen, you got a choice. You've got 2 years to go solve this problem. After 2 years, I'm going to go solve this problem. So do what you want." And of course, they didn't solve the problem. And 2 years later, we went off to solve the problem. So that's what you're going to see now. This is a web. This is a web interface in a new platform that we will be shipping. The details of which I'm not going to go into, but hopefully you get a feel for what it's about. And what we're seeing here is just a real-time graph. This is the same system in Menlo Park that Adam was looking at earlier with the NFS provider. And what we're just seeing here is very simple stuff. We're seeing the number of NFS v4 ops per second sitting in Menlo Park. Now, wait a minute. Stop. Whatever it is you're doing right now. No. I know you're 2 ops, no good. No, the 2 of you away from the keyboard. I know. I can feel it. I can feel there's like Brian sucks his own balls as a file that's being accessed right now. Stop it right now. I just like. Yeah, there you go. Exactly. I know what that is. All right, so you've seen, for example, the load on this NFS server just skyrocket as everyone is now struggling to access all the files with various dirty names. But this is ultimately, and amazingly enough, this is actually even as crude as this is better than a lot of the existing stuff out there. But this is still very coarse. This is basically case sense, right? It's happy sad. That's all this is. And like this isn't even happy sad, right? This is just number of ops. Number of ops is not necessarily, it's only indirectly related to happy sad, right? Because if I'm doing 10,000 ops, but I'm cranking on them,
and they're coming out at 100 mics a pop, like, that's not sad, that's happy. But if I'm doing like 4 ops, and they're taking 4.5 seconds a pop, that's sad, that's very sad. So this isn't even happy sad, it's not even that good. But still, we want to have, we want to understand this better, and of course we want to use the dtrace metaphor to do that. So what we allow you to do is click on this. I mean, these are our various icons to explore the graph and so on, and zoom out and what have you. And what I'm actually going to do is click on this little power drill icon, and we're going to drill down. And we can drill down by type of operation, send best by client, by file name, and we'll get to the.
Try latency.
Well, we'll do latency later. Latency is the special sauce. We'll get to that in a second. We can't get too excited too soon. It's called foreplay. So let's just do by type of op. That's kind of that's a case that isn't. So we'll kind of skip that. Let's just do by client. And what we're going to see now is we got a new graph here, and now we're actually seeing the same data. But now, in addition to the kind of graph here, we see actually, yeah, you guys are the best. Girl talk on SFA, you know, don't do too much loader. We're not gonna. We'll actually. We are going through a soda straw here. So if I want to click on these guys, I can see how much traffic is accounted for.
I stopped.
What's that?
See, go back up to girl talk. I stopped.
And you know, this is obviously using dtrace under the hood, but we're abstracting it away. We're writing a dtrace script dynamically on the server. But the real power of this comes when we actually start looking, not just breaking down by client, but breaking down by, say, a specific client. So take Voss X4100-GMP03.UK. John, is this you? I don't know. So well, let's figure out who it is. And so I'm going to drill down on this client, and now we can drill down by type of op, by file name, by latency, and so on. Maybe we'll just do by type of op for now. And now what we're going to see is a wholly new graph. And so here we don't have any data because we're asking this question for the very first time. And what has gone on in the background, of course, is we've written yet another dscript. So we're constantly writing new dscripts on the server, scoping that information out. And we can see, for example, we're doing some printfhs, some getattrs, and so on. So what printfhs are we doing? I mean, we're obviously doing some. The printfh is an NFSE4 op that essentially amounts to a write. What are we doing here? Let's drill down on that printfh by, say, file. And now what we're seeing is NFSE4 ops per second for that particular client of that particular type broken down by file name. And we can see what awesome. Actually, this is a bug. Actually, that's not actually correct. As it turns out.
Well, it's spelled wrong.
And if we go actually up to so this is for this particular client, which they apparently Brendan has managed to RSH that client as fast as SSH you can. He's going to Voss X100 SSH. Please let me log into this box.
I was on the Atlantic. How did they get there?
They're there for me. Damn, waiting for me. Bastards. So let's actually, we'll get rid of that. And actually, let's just look, instead of drilling down on that particular client. And by the way, I can save these data sets for later if I want to look at them over or I can just discard them. And I can also save these investigations because we found that it's very useful. You'll dig deep on a particular investigation, and that will be kind of relevant for you, so you can save that as a worksheet. We call it a worksheet. And you can come back to that investigation if you think you're having the same problem. So let's actually, we'll get rid of the by client and just do by file name. And I'll go ahead and show this to you hierarchically if we're not active for accessing more than one file. There's again command access, of course.
So drill on all clusters or specific clusters?
What's that?
Can you drill on every cluster or only those which random stuff?
Can you drill that? I'm sorry. What?
So can you go, for example, for a growth problem, see what's going on?
Yes, you go to drill log and see what's going on in drill log. Yeah, you can drill down whatever client you want because it's just interesting back, right? It's doing, all we're doing is we have, it's a visual metaphor for exactly what we all do when we're running dtrace. We run dtrace, we see some output, we say, what the fuck is that? It's a girl talk. Again, predicate girl talk. Oh, okay, wait a minute, why are we doing that? Predicate again. It's taking that search tree that we all do when we're looking at a system and expressing that visual, which I think is part of what's novel here. I think is that I said I have nothing against instruments or the like, but they're much more focused on the developer, and they don't capture that uniquely dtrace metaphor about the way we explore problems. So here I can see the various home directories that are being accessed. There's DP. Dan was desperate. Please find my file. All right. Well, I'll just give you your. Oh, look at that. Oh, Dan's actually doing useful work. You know, you two jackasses.
Yeah.
Really
I'm doing fine. Thank you very much.
Well, it looks like useful work anyway. And again, we can also click over here if we would rather do it that way. So it's highlighting the various files here by its wedge. I love pie charts, so it's not going to do that. And again, allows us to understand quickly what this actual box is doing. This box is an NFS server, and it serves up NFS. But you can imagine on a router, you want to know what is the router doing? Who is, we're on our wireless network, who is uploading some gigantic file that's making it such that everyone's being crippled? Well, you can do this very quickly and understand it very quickly, and save that data for later and so on. So we think it's actually a pretty powerful visual metaphor. It's been very fruitful for us in terms of just understanding the way our systems are being utilized. And in particular, it allows us to do visually what we have done with dtrace manually, and that is find that stuff that's higher up in the stack. Right? We have a SIFS server now in Solaris, and that SIFS server has a SIFS provider. That's exactly very good. The SIFS server has a SIFS provider. We'll have a SIFS provider. That SIFS provider will allow you to do this for SIFS. Can you imagine, talk about shining the bright light into the black hole? I mean, talk about a target-rich environment. If you've got a Windows environment, you know that as soon as you turn that on, you're going to discover so many pathologies. Windows clients gone batshit insane all over the place, right? And you're going to find all sorts of pathologies here. One example that we find persistently are things that are temp files being stored in home directories, right? Instead of being on /temp. A good example of where you can actually save yourself the cost of a bigger machine by making architectural changes. So this stuff is valuable. We think it's interesting, and we support you. We allow you to do this for a very wide variety of statistics. Things like you can get disk I/O ops by disk and so on. TCP packets by. I'm not going to click on that. Whoever said that, you're not getting clicked on. I'm not going to reward that behavior.
So, Brian, what do you mean when you say you're not going to click on that? Does that mean that you can just click on it and learn more things about it?
Yeah, I can. If I want to. Wait a minute! Nice try. I'm going to click on it up here.
Well, Brian, what I mean is,
and I will. What it's going to do? It's going to highlight this value. I saw 5,442 ops. If I wanted to, and I guess I can't resist the urge to synchronize these two, and now we're going to know. I don't know. I don't know what this is, and I'm not clicking on it. It's export something, so
Let's scroll down.
So you can. Just get it. Let's just get it over with. What am I sucking now? Oh.
Russ is doing work.
He logged in, it looked like.
Russ is.
Is he browsing porn again?
Actually, it's interesting.
It looks like he logged in or something.
Yeah, maybe he logged in. Yeah, those could have been. Yeah, that's actually interesting. So you can really freak Russ out by calling him up just now and be like, why are you logging in? You can see all sorts of things by this way, by the way. It's kind of scary. You can see, and I'm always working with a demo. You never know what you're going to see, and you never know if you actually are going to see something incriminating.
So I guess, Brian, that wasn't quite the question I was trying to ask.
Yes.
What I was trying to ask is, if you pick a particular point in time, can you then navigate to the other statistics that were in that drop-down box?
Yep.
Is it all captured all the time?
Yeah,
or
so
only when you ask?
Only things that you have saved are captured by default. And you can save whatever you want. So, and if you bring up a data set that you've never seen before, you're going to see all those hash marks. If you bring up one that you've seen before, then you're going to see, so for example, if you want, we could actually, let's go to before ops per second, and let's just look at that over, say, the last hour. And let's click on the max there. And then let's, so at 4:37:22, we had the maximum number of ops. If I were to now add or drill down by, say, client, we're saving that information. So when this guy comes up, he's going to come up with that, and there's Loris highlighted there. So it allows you to very quickly correlate. And the one thing that's cool about this is you can, you come in the morning, and you see that something that you had a huge amount of traffic overnight, you're trying to figure out what was going on. You realize that you had the backups were running simultaneously to 2 different places, or that you had an IMAP server went nuts overnight. So you can very quickly correlate something that happened in the distant past. One example I don't have saved here as a worksheet, but I do on our local machine. It's kind of interesting. Is notice that when I would run Firefox, it would take like 8 seconds to start, which is the very worst time for those of us who do performance and are impatient. Because 8 seconds is just long enough to really piss you off, and yet it's short enough that by the time you're like, right, fucking running dtrace, what's going on? It's like, oh, it comes up. And this is actually maddened me enough to the point where I'm like, I would actually go look on the server and look at our analytics on the server and just see what's going on. And I had all sorts of dumb, wrong ideas, as we frequently do before we start to use dtrace, about what was going on. And I see, sure enough, there's a ton of networking traffic at that moment. I'm like, okay, and I'm thinking Firefox is, scanning my home directory, or I don't know. And I look, and it's a bunch of reads. Okay, it's a bunch of reads. Okay, what files are being accessed? And the file it's accessing is home BMC, record, whatever. And I'm like, okay, clearly I'm like bugging analytics, bugging dtrace. We're not reading a core file. That does not make sense at all.
Oh, this is Firefox.
No, it's Firefox.
Yeah, so I spend like 45 minutes doing like going through the entire tool chain in my head, being like, we're clearly screwing up somewhere because we're not reading a core file. And then at some point I'm like, I should just go look at the Firefox, like the running Firefox script. You know, I think it's like, first thing it does is like, oh, there's a core file here. I'm going to do an MD5 sum on it and send it off to Firefox Central or whatever. Which is the most retarded thing I've ever done in my life.
So
it's like, first of all, like, what kind of low self-esteem do you have to have to assume that any core file was generated by you? I mean, stand on your 2 feet for a second. So it assumes that any core file was generated by you. Although that said, maybe it's not such a bad assumption. And then we're going to read a core file. We're going to do an MD5 sum on it and send it back somewhere. Okay. Just walk me through this. What does that mean exactly? I've taken what is effectively line noise, and I've checked some. It's like, are we validating MD5 sum? Are we validating the NFS reads? What are we validating exactly? Because God knows you can have 2 core files, same mythology, different checksum. Boy, how did that happen? It's like, what do you mean I don't have this exact same address space?
Brian, I think it compares the core file since the last time it started up. And then it won't recheck it after that. But the thing is, we found this when somebody had an 800 megabyte core file in their home directory.
That's right. I had a 1 gigabyte core file.
Yeah, there.
That was not commit. That was from somewhere I wrote. So, and I think that, and this is an interesting example how this could be a serious issue. When you're running a call center where you got 200 people hanging off using browsers all the time, and I mean you have an outage or something, and you have 200 people starting up their Firefox simultaneously. And you've got a very serious performance issue that kind of unbelievably was inscrutable before using dtrace. Now you can use dtrace and not have to actually know that you're using dtrace. So the ops are great, and this is valuable and interesting. But as I said earlier, ops are only part of the story. Because ops don't necessarily correlate to happiness or sadness. I mean, there is the correlation coefficient is there is a correlation, but it's not necessarily what one might think. So what we actually like to do as well is, and let's kind of zoom in up for a minute again. We'll put Loris here. Is instead of before I was drilling down by client and so on, now let's drill down by latency. And now what we're going to see is a different kind of plot, and a different kind of visualization, where the color of each of these denotes the frequency of that event. And on the y-axis here, you have time. So I can see kind of where my outliers are. So I can basically see I am most of my my NFS activity is happening very quickly, but I am seeing outliers into the tens of milliseconds area. And if I want, I can. So actually, let's zoom in on the ones that are quick. Say the ones that are less than 3.26 milliseconds. And if I want, I can prune out. So now I'm just looking at the ones that are below 3.26 milliseconds. And I can begin to get a flavor for what, and I can take one of these, and if I want, you know, say the ones that are, let's say, above a millisecond. If I want, I can then go drill down on that, say, by client or by file name or whatever. Let's do by client. And now we're going to see a wholly new enabling. These are NFS v4 ops, taking at least 993 mics, broken down by client. And now we've got count again. And now we continue to iterate and drill down. And as Brendan alluded to earlier, latency is where it's at in terms of, because ops, happiness or sadness, who knows? Like IOs taking 150 milliseconds, that's sadness. And it's indisputable sadness. Scheduling latency taking hundreds of milliseconds, that's sadness. And it also allows us to validate when you got caching tiers in something like storage hierarchy. It allows you to validate those tiers, make sure that they're doing what you expect them to do. Make sure that if you expect this workload to hit the DRAM over my NFS server, you can validate that you're hitting DRAM versus hitting the disk. You can imagine tying this in more closely with things like Postgres, where you can actually start to see the latency on a per table basis. And so all this stuff, by the way, and I can't talk in too much detail, other than it's going to be hitting the market soon-ish. Again, given the way we hit our schedule today, you got an idea of kind of what our schedules are around here. But all this will be open source, and you'll be able to plug into all of it. So for those of you who are interested, it's like, man, I would love to take Postgres and plug it into it. I'd love to take Ruby and plug it into it. I'd love to take, you're going to be able to do all. Interface is still get crude, but you'll be able to do it. Yes? It's Java? No, this is JavaScript on the client and C on the server.
So how serious is AKD?
What's that? The mysterious Mr. AK. Yes.
The open source part solves a big part of the problem, but when I first started looking at instruments, I said, this looks really cool. And then I said, well, wait a second. The only providers I can put in are dtrace providers, so I can't put my own data in along with it. And I can't do anything with the output format. And I can't do any functional analysis on the data, you know, to subtract two values or whatever. And so I guess what I'm wondering about is what possible direction to think about curing this is to allow users to say, okay, I want to do the following function on the following data, and then make that one of my options.
Yeah, and I think that we probably will go there ultimately, to be honest, and this is where I think that I kind of diverge from some of the previous thinking around people putting user interfaces on top of dtrace. I'm really not into the whole, like, input your dscript here and then I will visually interpret. Because I think you have to go up further in terms of layers of abstraction. You got to get to the point where people don't even know there's dtrace in this. Now, we want to allow you to still plug in dtrace, arbitrary dtrace in the back end. And we will allow you to do that, and we do have an interface allows you to do that today. It's just a bit clunky.
When you started showing up, you were actually showing visualization of case banks. And
yes.
Then seamlessly transitioned into dtrace. So if you have different data sources, that'll all be possible.
Yeah, that is true. That there's nothing that that the backends here it knows how to go from KStat. And so in particular, we don't necessarily want to have dtrace enabled all the time. I mean, you can for certain applications, but if you can avoid it, you have to try to avoid it. So when we're looking at NFS v4 ops per second, that's just KStats. There's no dtrace involved. It's only when I go to drill down that I actually get dtrace involved. And the numbers actually end up being insane.
Where is the data stored?
The data is stored on the server.
And what format?
The data is stored because the kind of queries this thing needs to allow are unusual in that we want to be able to allow you to zoom way, way out on the data. And so you want to be able to zoom at weeks and months very quickly and dive in when you see things that are interesting. So we aggregate that data up and up and up and up and up and up. So you can look at very, very long spans of data extremely quickly. So the actual back end is our own Goober, but will allow you to get at all that via common separated values. So you can sort it, and to your point, Rich, you can sort it and do what you want with it.
Does it store everything, or does it never retain open windows like after 3 weeks it starts throwing away per second data?
No, it actually will never throw away per second data at the moment because we've got drives are big, and we've got storage that we got nothing else to do with. And ZFS compresses really, really well. I get like 12x compression on.
So LZJB or GZIP?
I think I'm using GZIP, I believe. I don't know. That was LZJB. LZJB gave me 12x. God already knows what GZIP will do for me. Actually, a really good kind of meta point on ZFS related to dtrace. When you're developing your own file format, don't develop compression in the file format. Use ZFS and have it just ton compression. Much simpler.
But someone was about to say we store per 30-second data on stuff, and we look at like 200, 300 megabytes in that.
Yeah, and so you won't get anywhere near that because the data that you at your second, the data you're gathering is actually pretty modest. Now some of this will get aggregated away. If you have 10,000 clients accessing you per second, those are still going to get hashed and aggregated away. So you're still going to, unless you've got kind of 10,000 different clients accessing.
So when you go back in time, you can't look at other things. You can only see exactly what you saw.
What do you?
You can't look at data that you weren't gathering.
You can't look at data you weren't gathering. Yes, it doesn't. I mean, it can make some stuff up.
No, I mean, you're not looking at that. Are you looking at that? Are you on the left side? There's stuff in there.
Yeah.
It has. What is that? That's like. But when you were looking at files before, you had a number of files in there. So you have all the files.
All the
You're not
files.
storing all individual files, or are you storing every point for every individual file in there?
So yeah, so every individual file that's being accessed is being stored, but that's also being hashed and aggregated. So the now and that over time will get aggregated away.
So that if you click on a file, you can see you can see each individual file, right?
That's right.
But you can't aggregate that away if you want to be able to see each.
So we do aggregate it away if you are, as soon as you stop averaging 1 op a second, you will get aggregated away as we aggregate you up. So once you go down to the per second view and see that file being accessed for that 1 second, but as soon as you start zooming out, that file is going to disappear from your output because there's only access for 1 second. So right now we're able to prune data reasonably aggressively. Right now, put it this way, between us pruning data and spindle storage growing exponentially, things seem to be cool for the moment, but we've gotten an architecture that allows us to easily trim data.
I just wondering about the load, because this is running on the NFS.
Yep. And the load actually is
the top problem, right?
It is the top problem. Very good. But even on this guy, which is doing a lot of work, the load is actually pretty modest. Let's actually go over the visualization. This is actually, I should say, this is running a debug kernel. Let me be very clear about that. So let's break it down by application name, and we can see exactly what we're doing. So you saw versus CPU utilization as I actually kicked that off, but pretty trivial. And we're doing a shitload of work. I've got however many. If you go over my data sets here, these are all the data sets I'm keeping, and we've got. I'm keeping all sorts of crazy ass shit. I want to keep an eye on Brendan sent mail, and I want to keep an eye on Shrek surfing up. I just like to keep an eye on these guys. You don't see these guys. You don't trust them anything you throw. Just gotta keep an eye.
Brendan sent mail
So you have a lot of interest statements on here, and we're still seeing trivial CPU utilization because so much is being pruned at the source, right? So that's the power of aggregation. You've got very, very, very little data actually coming out of the kernel, even on a machine that's getting its ass kicked.
Yeah, so I see this, the future of this implementation with your master slave implementation, because I don't want 45 byte interfaces, right?
Yep, absolutely.
So, and then suddenly that master box is seriously going to be running. Because most of the stuff we monitor is somebody has CP metrics and ZFS IO writes and reads, and we store those in like 5-second intervals, and then you aggregate like the 40 data centers that we're looking at.
Right.
And you're looking at just the box that does monitoring affairs and everything.
Right. And I think that actually that's part of the reason why we implemented in C, that we are actually able to get the cost is actually pretty cheap, all things considered. And that's why we made that architecture decision.
Jared,
Jared.
Yeah, sure.
So just a quick question. Could you do like a latency breakdown by offset?
Yep. Now, you can't do both simultaneously. What you can do is you can take your high latency, and you can drill down by offset for that latency. So if I want to see everything that's taking, we can go back to that play. Everything that's taking more than a certain number of milliseconds or microseconds, I want to know what the offset is for that. So for example, this is by client. Let's take fluorescent sticker work. Here's to me. If I want to say, let's break down by offset. So that is now, we're now going to see file offset. So you can see we're getting some relatively complicated enablings under the hood. So this is going to be ops that take 99 mics or more. Come on, Morris.
Looks like less than home.
Yeah. It's quitting time, I guess. Yeah, not taking too much. But that, you would see, in any case, you would see your offset direction. Let's just look at ops.
I'll just SSH to Lars if I can get on.
Nah,
So you gotta get more than 993.
Here, do girl talk, man.
no, you know what? I'm not doing real talk.
Hey Brian, take a look at it now because I just logged into that.
All right, so actually, we'll just do NFS off by offset anyway. It's kind of so. So check that. And if you think you can spend a lot of time looking at this, you're right. So you begin to see different patterns of activity. Right? Here you can see someone is clearly blasting through some number of files. Actually, one of the things we want to do going forward is pump this through an FFT and actually give you, so take us from the time domain into the frequency domain. Right? I mean, how many times you're adding a box, and actually Keith has got a great more story about this, where exactly every 2 weeks, Friday, 3:30 p.m., like, this machine panicked or whatever it was. And it was due to a particular workload that was time-based. Oh, there we go. That's way out there. Okay, big fun. But you can see, you can begin to see different workloads. Am I streaming or random in terms of NFS? Say. This allows you to actually visualize that. And again, all dtrace with it.
So you can do this on other than NFS. You can do this on just plain old I/O.
Plain old I/O.
You can break down a process.
You can't breaking it down by you don't do I/O by process, but that would be easy to do. That would I/O. You're going to have some asynchrony there. I think I'm trying to remember I/O start. How frequently does I/O start fire in the context of the process in ZFS? Does that always? Will I/O start always fire in the context of the initiator in ZFS, or will that be?
No,
of course not.
No, when the transaction.
Then it's about a transaction. So yeah, by process is going to be tough.
For readers, if that's the one.
For reads, it'll be easy.
So you can find that there's two apps, one RFC.
And there's a lot that we want to do to kind of generalize this infrastructure, but you get an idea of where we're going.
How hard is it to add Magic Project?
Right now, a little too hard. It's still, it's not impossible. A bunch of folks on our team have done it. I'm not the only one who's done it, but it's still a little bit too hard, and we want to clean that up. You would be able to add, anyone in this room would be able to add a new metric without difficulty, but it's not to the point. It's not interfaces to what it's proud of. One being me in that sense.
Is it all run on OpenSlayer or run on Slayer?
This will only run on our distribution of OpenSlayer. So you'll see this. This is going to be as part of the Fish Workspace product that will hit the market later this year.
But you can use this on
Very little kernel stuff, but it will be a bit of an exercise to rip this out and put it on stock Solaris, but one could do it. We have a little wager going around the office about how quickly it will take one to do this. Schrock is maintaining that, Eric Schrock is maintaining that this will happen roughly 30 seconds after we ship. Maybe by someone in this room. It's definitely possible. We probably won't do it, but it's definitely possible. Oh, there we go. Now we got some. Now we finally got that big guy off. Other questions?
Who does the descript?
You can see the descript. through a debug mode, you can actually see the dstrings if you're interested. I mean, we don't plan to spit it out, but you can actually, it is kind of interesting to look at, to look at what it's generating. But no, we don't spit it out by default. Other questions? Okay, thank you very much. Okay, so we are, so who else has things on visualization? Okay, good. We are now going to be, did you go down to the door?